So hey, I kind of helped to build and to operate in the meantime more than 10 recommendation systems, and we've learned quite some things from that, and I would like to share some of these lessons because I think they are really interesting for people in the field or in related fields. Before I start, maybe interesting to share my background with you. I have a background in academia, so I did academic research on the recommender systems. And I had the luck to be able to work together with people from Netflix and Apple on this technology, and really seeing that they were getting enormous amounts of advantage from correctly using recommender systems, while, well, let's say the rest of the world, besides these digital superhero companies, were lagging behind. So there became this frustration. Why is everybody not doing this? So yeah, there's only one way trying to change that, and that's to start your own company trying to do that. And that's exactly what we are trying at Froomle. So what you will see is the lessons that we learned are very much things that are not written in books, that are not taught at university, and that are also not a part of scientific literature. Because that's exactly why these were lessons for us, because we knew all those books and that literature, we even contributed to it, but yet we saw that there were many, many things to learn. I have learned a lot. I have put 9 lessons in slides. Given the time, I think we will at most get at lesson number 5. If you want to know more, you can talk to me later. Lesson number 1 is, if it comes to evaluating approaches and comparing different approaches next to each other, online evaluation, meaning evaluating something really in production, is order of magnitude better than testing it on offline data sets. And that's really very specific for recommender systems. You don't have that, for example, in face recognition. Somebody is a woman or a man, that's pretty clear. It's a cat or a dog. But in recommendations, you will see it's quite more subtle. So let's show you why. On the slide here, I have 3 persons and a typical experiment. So what you see here is 3 persons. You have their time history, and every blue dot represents a purchase of this person. So what is typically done to evaluate 2 approaches is, for every person, you randomly remove one of the purchases. And then you will try to find this purchase, to predict this purchase that you have left away. It's called leave one out cross-validation. And if you do it, you will see, and you compare 2 approaches, you will definitely see that one approach can be much better than another, right? However, there's a problem with this. Because for all of these red dots, you are using the future to predict the past. And that's cheating. Now, it might seem obvious that you can't do this, but like 80% of all the significant work, scientific work in this domain is doing exactly this. So if I tell it to you like this, it seems obvious, but in reality, people are, well, I think they're trying to forget it because there's no easy solution. So, okay, there is a better way. And the better way is that, well, you just draw a line in time. Everything left from the line, that's the data that you use for training. And you will try to predict for every user the next purchase. The ones further on the right, you forget about them. That's further in the future. What you will see if you do that is that, first of all, performance drops dramatically. Yeah, of course, you can't use the future anymore. Secondly, differences between different approaches, they also decrease dramatically. The difference in performance between different approaches really becomes very small. But there's still a very big problem with this one. And that is, when you collected the data set, when you were collecting it from your website, let's say, Well, there was an algorithm running. Even if it was a person handpicking certain promotions, let's say, well, that's also some sort of algorithm. There was a policy determining what was shown to everybody, and it influences the data. Now, what we did is, okay, we had a data set with a certain policy, a logging policy we call it, and then we just changed the policy, so we collected a new data set and we did exactly the same evaluation. And what you see is that the results just changed. So now suddenly, because we just used another data set on exactly the same application, now the first approach was better than the second. So which one should you choose based on these kinds of experiments? The conclusion is that in this way you are not really measuring which of both approaches is the best one. You are rather measuring which of both approaches is most similar to the logging policy. Which approach resembles most the approach you were using before. That's not really what you want to do, right? So in my opinion, offline experiments using historical data to score and compare recommender systems, I didn't want to put it in writing on the slide, but my opinion is it's useless. So you really should put it in production, A/B test it, and really see how people's reaction is on it. Also, and that's adjacent to this, is still part of the first lesson, there's a difference between prediction and recommendation. What you're testing with these offline methods is how good are you at predicting the behavior that somebody already posed, that this person would do anyway. If you're good at this, the best that you can do is remove friction of something that was going to happen anyway. I'm not saying that's bad. It can be interesting in certain cases, but what you're really looking for is recommendation, showing something to somebody that he or she would not have found otherwise. And that's something that you only really understand, really at the deepest of your heart, let's say, if you are not scored on how good your prediction is, but let's say on the additional revenue your solution provides. Because that's when it really becomes obvious whether you are making additional consumptions, yes or no. Lesson 2 is all these, or most of the well-known recommendation approaches, they learn from historical data. And that's good and that's necessary. However, even equally important and often overlooked is that how people react to recommendations, to actually giving the recommendation, what are they doing with it? That's at least as important as all the data that you have collected until that point. Because I want to ask you a question. If I get a recommendation and I do not click on it, would that be a bad recommendation? Who thinks it is bad? Put your hand up. Okay, that's reasonable. There may be many reasons why I did not click it. If I would get the recommendation 10 times and I chose not to click it 10 times after each other, who would think it is a bad recommendation? Okay, I also think that. And what we're talking about here is what we typically see is something like this. The first time you show something, the probability of clicking is not maximal. It's rather around, and it really depends on the case, and it depends on the position on a website, etc. But typically around the 4th time, oh, here says a 3rd time, no, it doesn't matter. 3rd or 4th time that you show something, the probability that somebody clicks it is maximal. That means there must be some kind of effect of people getting aware of something that you recommend to them. As people go somewhere with a certain intent, you show them something else, they see it, but they go after their intent. If you keep showing it, then, oh yeah, this might be interesting. Then, after that point, the probability of clicking something drops, and at some point it rather drops dramatically. This is, of course, only a symbolic graph, but typically you have around 8 to 10 times showing something and not clicking it. the probability that is going to be clicked is only 50% of what it was when you were at number 3. Typically at this time, you have discounted the score of this recommendation so much that there are other alternatives that are better, and therefore it disappears from recommendation lists. This is what they call impression discounting, and it has really a major influence on performance. So that's a big lesson. There's a paper about this from people at LinkedIn describing every gory detail of how you should do this. A very similar thing is boosting. It's not about people not clicking, it is about you have a recommendation and there is a reason why you recommend it. It's typically part of the history of some user. Let's say I'm recommending you batteries, and it is because you bought 3 products that fit with these batteries. So this combination of these 3 products and these batteries, it's really the click-through rate of that recommendation is much higher than you would have expected before based on historical data. Well, if that is so, if you see that happening, well, then you should boost that combination because that's information you should use. I see that the link is not here, but Pinterest has a very interesting paper on this where they show how much impact it had for them. Third lesson is, well, there is this ever-going debate. What is more important, having more data or being happy with the data you have and making better models? Well, of course, the answer to that discussion is it depends. If you have a lot of data, it makes sense to improve your model to some point where it is more complex and can find all the, let's say, the details in the data, and then there is again this period where you can use more data to feed them all, etc. But that's not what this is about. There is a third dimension that is overlooked in this discussion, and that is the diversity of the data. Because in recommendation, people invent and publish a lot of algorithms, and these algorithms are then tested in their experiments in the wrong way, as I showed you. Mostly, unless they're from Netflix or Google, then they have, of course, live systems. And then they test this on different kinds of data. Who's viewing a movie, who's buying a product, who's rating a movie, who is liking a certain piece of music, who is playing music, all these kinds of data. But they are making abstraction of what the data is. They're saying, yeah, it is some person expressing a positive preference for some item. But there is much more information in this data. So typically you have somebody watching a product, somebody can like it, can even add it to his or her cart and purchase it. And all these things mean different things. Because if you, for example, want to make a list of alternative products, you will use this data in a different way than if you want to make a list of products that go together, that cross-sell together. And so for the alternative products, it might make sense to put a lot of weight on things you view, because when you are considering alternatives, you're watching all of them. However, when you are looking for cross-sell products, it's about what people buy together. And then you're looking rather at purchases. So there's a lot to be gained by considering all this data, not just throwing it together, but really knowing what it means and knowing how to use it for different purposes. Which is related to lesson 4, and that is a very hard problem, and that is the problem of mutual exclusivity that you need to try to solve. This is an example where you have a list of non-fiction books, and 3 out of the top 5 are actually exactly the same book. This is a waste of screen real estate. The reason, of course, is that it's the paperback, it's the hardcover, it's the e-book, but really I don't care about that. I want to first go to the book and then I want to choose how I want it. However, you can see that there are possibilities to know that these are actually mutually exclusive products, that these are substitutes for one another. And that is, well, I would not be surprised if all these three books are very popular. Well, Michelle Obama, she can sell a book or two. However, although they are very popular, I would not be surprised if almost none of them are bought together. Why would you buy 2 out of 3? That's the reason I don't want them to be all 3 there. So if that's happening, you might have some features that learn you these are mutually exclusive objects. And there is more. Although almost nobody buys them together, it might be, and very likely so, that a lot of people are watching them together because they are considering which one of the 3 to buy. And then finally, I would also not be surprised if, although they are not bought together, the things they are bought together with are more or less the same. So that is a lot of information that you can have to know that these are mutually exclusive products. And I can tell you it's possible to filter them out. Which brings me to lesson number 5, and that is that measuring whether one approach is better than the other, even if you do it online, in production, in a real system, is still very hard. Much harder than you might think. And I'll give you an example. So you have here an e-commerce store, and this is the product detail page. And on the product detail page, you typically have a feature bought together with, watched together with, goes well together with, whatever, cross-selling. And you have 2 approaches for that, doing exactly the same thing, but in a different way. So you want to select the one that is best. And our first, so we put it in an A/B test, we let it run for months even, and we see, well, or let's say a year, and the way that we first measure it is, well, we will see how much is this box selling in both cases. So how do we measure that? Well, let's say if we recommend something, and then the person clicks on it, and within half an hour that person also buys it, I think it's pretty reasonable to say that the box sold that product, right? It's really very, very causal. You show it, you click it, you buy it. No other ways. And then you see, well, approach 1 in this way does sales of 20 million a year, but approach 2 is double as good. It sells 40 million a year. So you might conclude, well, that's pretty clear. Let's go for approach number 2. However, you present this to your management, and there is this very smart manager there that says, yeah, that's like micro conversion, that's an intermediate result. You only convince me if you show me that the total sales for approach 2 is also 20 million higher than the total sales for approach 1. Sounds reasonable, right? So you do the test, because you're pretty sure it will be the case. The data speaks for itself. So you do the test, but you are surprised because it's exactly the other way around. Approach 2 only sells, is part of a solution. It's a small part of a solution that sells 1 billion a year, but approach 1 is part of a solution that sells 1 billion and 20 million euros a year. So now it's exactly the other way around. What the hell is happening? Well, this is where it becomes difficult, but therefore also interesting. What is happening is that there is a lot of spread on this sales number. So what you could do is you could put approach 1 live for everybody for as long as you want. And then, so you do that, and then you sample groups of 50% of the population, and randomly. And you do that a lot of times, thousands, 10,000s of times. What you will see is that the sales number from this random group of 50% of the people, yeah, it varies. Sometimes there's some heavy hitters in there, sometimes there are some cheap bastards in there. So there's a little bit of variation. Although you have a lot of people, yeah, this variation is not 0. Actually, the variation in these kind of cases is pretty big, and what you are seeing is that, on average, you could expect to do a turnover of 1 billion and 10 million a year. However, the data that you collected in your previous A/B test comes from this random distribution. And it gives you, for approach 2, only 1 billion, and for approach 1, a little bit more. But what you are seeing is that from this test, the only conclusion that you can draw is that you cannot say there is a difference between both methods from this test. So you cannot say that, let's say, well, here method 2 was doing more because it was cannibalizing on other positions on the page or something like that. So the conclusion here is that because of the big spread on the total number, you should look at this one is much more interesting than this one. There's a lot of variation on the total revenue. So looking at small differences, although 20 million, if I would realize that, I would pay back my paycheck, I would say, and earn a good bonus. But on total sales figures, this is a small number, and it is well within one standard deviation, and therefore you can't really say anything about it. Okay, we have 4 minutes left, so I can do at least one more lesson out of the 9. So lesson number 6 is, please do not forget anonymous visitors. People have the tendency to work for the best customers. They are logged in, they have a lot of data, you can get a lot of nice results for them. However, anonymous visitors are easily, and of course that depends from case to case, but are easily at least 50% of the visitors on a website. Now, they have no purchases, so if your approach is based on what somebody purchased, then you're already neglecting them. However, they have views. So that should be one of your major concerns, to be able to make good predictions based on what people view, not only on what they buy. And then more severely, they are not only anonymous, they do not only have views, oftentimes they only have 1 or 2 views. So they have small data. But still, and even more severe, because a lot of these people are new, you only know their views for, let's say, 1 second. And so they are doing these views, but they only did them 1 second ago. So you should now personalize for them, but you did not have a lot of time to compute what they would find interesting. However, although that there are all these challenges for these people, I believe that it is very important to have a solution for them, because they are your new potential customers. If you can give them a good solution, they will start buying, or they will become a loyal customer instead of a very sporadic customer. And the lifetime value that you will get from them is very important. Which brings me to the next and final lesson, and that is really related. That is, history is only good for a certain part, at least as important as history is somebody's intent at a certain moment. So you have my history, of, let's say, my wife's history until a minute ago might have been this: children's books. We go somewhere to buy books for our children. However, last 30 seconds, my wife looked at this book. So if my recommendation system is not blazingly fast, these are the recommendations on the homepage. Of course, not what you want. These are the recommendations if you would be able to take into account the intent of the person at that moment. So I hope you see that that can be very important. It is crucial to be real time. And actually what's happening here is, although this person might be logged in, this part of this family, this interest of this person was anonymous until that point. So it's very related to the anonymous case, and both cases, both lessons are a reason to be as real time as possible. And then one more, I have 38 seconds. Has also to do with speed, but now not of giving the recommendation, but of updating your model. The reality changes blazingly fast, and we react in the moment. There are, for example, a lot of events, and I have Here too, typical events are sporting events. The great team of Ajax, I don't know whether I can say that in the city. Well, they, against all odds, they beat it Real Madrid, and it's like world news, and definitely in Holland, people will be very excited about it. And people go to web shops to buy stuff related to that. If your model is not able to pick up that signal, to update soon enough, then it will miss out on the opportunity. 24 hours later, 12 hours later even, the enthusiasm has dropped. The rage is over. And therefore you have missed a lot of opportunities. Same thing, another typical example is when famous people die. Then people also start buying stuff about them, or suddenly interested. They're all over the news. People, oh yeah, sure, I wanna see things about that. So there are these events. They are very momentary, and you have to seize them in the moment. And that's only possible if your model of reality is able to pick up that behavior, meaning that you should be able to update your model at least every hour. If it's slower than that, it's really difficult to capitalize on these things. This one I will skip. So the reason I did this talk is because I want to learn from other people. So if you have things to say about this, questions, sharing your own experience, please talk to me later. Connect with me on LinkedIn, call me, email me. If you're not a talkative person, you can maybe watch our YouTube channel. Thank you for watching and for listening.